Okay, picture this. It's around 585 BCE. Two armies, the Lydians and the Medes, are locked in a brutal battle. Swords clashing, blood everywhere, the whole 9 yards. And then, the sun starts to disappear. Now if you're a soldier in 585 BCE, you know exactly what this means, right? The gods are pissed. This is divine intervention. This is the universe itself telling you to stop fighting. Both armies drop their weapons. The battle ends. A peace treaty gets signed on the spot. But here's what's remarkable, and this is where our story really begins. There was one guy who saw this coming. Not because he had divine visions, not because he consulted oracles or read animal entrails, but because he'd been paying attention to patterns. He'd been doing math. His name was Thales, and he just changed everything. See, what Thales did that day wasn't just predict an eclipse, though that alone would be pretty damn impressive for 585 BCE. What he did was introduce a radical idea. That the universe operates according to natural laws that human beings can understand through observation and reason. Not mythology. Not divine whim. Not because Zeus said so. Natural. Laws. This might not sound revolutionary to you. You grew up with science, with the scientific method, with the assumption that the universe makes sense and we can figure it out. But in Thales' time, this was heresy. This was dangerous. This was the beginning of everything we now call philosophy, science, and rational thought. Throughout this lecture, we're going to explore how one man from a prosperous trading city in Ionia fundamentally altered the course of human intellectual history. We'll look at his contributions to mathematics, his theories about the nature of reality, and why, 2,600 years later, we're still talking about a guy who thought everything was made of water. Yes, water. We'll get to that. Trust me, it's weirder and more brilliant than it sounds. So who was this Thales character? Well, let me tell you. He wasn't some ascetic monk living in a cave contemplating the cosmos. Thales was basically the ancient Greek version of a successful businessman who got really into side projects. He was born around 624 BCE in Miletus. And here's what you need to know about Miletus. It was basically the Silicon Valley of the ancient world. Prosperous trading hub. Cultural crossroads. Ideas flowing in from Egypt, Babylon, Phoenicia. If you wanted to be where things were happening in the 6th century BCE, Miletus was the place. Thales came from money. His family was probably involved in trade, which meant he had two things most ancient Greeks didn't have: resources and exposure to different cultures. He traveled extensively. Egypt, Babylon, probably other places we don't even know about. He soaked up mathematical knowledge from the Egyptians, astronomical observations from the Babylonians. But here's what makes Thales different from just another well-traveled rich guy. He didn't just collect knowledge like souvenirs. He questioned it. He tested it. He tried to find the underlying principles. The Egyptians could calculate the area of a triangle? Great. But why does that method work? What's the principle behind it? The Babylonians could track celestial movements? Fantastic. But what causes those movements? What's really going on up there? This insatiable curiosity, this refusal to accept "that's just how it is" as an answer, this is what makes Thales the father of Western philosophy. Not because he had all the answers. He definitely didn't. The guy thought everything was made of water, for crying out loud. But he asked the right questions. And he insisted that those questions could be answered through human reason rather than divine revelation. Now, Thales wasn't just an ivory tower intellectual. He was involved in politics. He was involved in commerce. According to one story, probably apocryphal, but I love it anyway, his fellow citizens used to mock him for being so impractical, always lost in thought about abstract concepts. So one year, Thales used his astronomical knowledge to predict that the olive harvest would be exceptional. He quietly bought up all the olive presses in the region when they were cheap. Harvest time comes, olives everywhere, and suddenly everyone needs to rent Thales' olive presses. He made a fortune. The point wasn't the money. He was already wealthy. The point was proving that philosophers aren't impractical dreamers. We can engage with the real world when we want to. We just usually have more interesting things to think about than olive presses. But let's get to what Thales is really remembered for. Let's talk about the mathematics that changed geometry forever. All right. So we've established that Thales was this curious, well-traveled businessman philosopher who refused to accept traditional explanations. Now let's talk about what he actually did with all that curiosity. Because here's the thing about Thales. He didn't just observe the world and make clever guesses. He created proofs. He took mathematical knowledge that had been floating around the ancient world, practical tricks the Egyptians used for surveying land, techniques the Babylonians used for astronomy, and he asked a question nobody had really asked before. But can we prove this is always true? This is huge. This is the birth of mathematical proof as we know it. Before Thales, mathematics was basically a collection of useful recipes. If you want to find the area of this field, do these steps. If you want to calculate when the Nile will flood, use this method. It worked, but nobody really knew why it worked. It was like having a cookbook without understanding chemistry. Thales said, "No, we need to understand the underlying principles. We need to demonstrate why these things are true." And this is where it gets beautiful. Look at what's on this slide. 3 major contributions. First, Thales' theorem. The theorem that still bears his name 2,600 years later. The idea that any triangle inscribed in a semicircle, where one side is the diameter, will always have a right angle. Not sometimes, not usually. Always. Think about that. Thales looked at circles and triangles and discovered an eternal truth. A relationship that was true before humans existed and will be true after we're gone. That's not just mathematics. That's touching something fundamental about reality itself. Now, I know what some of you are thinking. Great, Professor Leshley, another dead Greek guy and his triangles. When am I ever going to use this? Fair question. But here's the thing. You already are using it. Every time you use GPS, every time a building doesn't fall down, every time an engineer designs literally anything, they're building on the foundation Thales laid. The idea that we can discover universal truths through logical reasoning? That's Thales. But let's look at his other contributions on this slide. Second, he established the relationship between an object's size and its distance from an observer. This is the foundation of trigonometry, of surveying, of navigation. Thales figured out that you can use proportions and similar triangles to measure things you can't directly reach. Which brings us to third, his methods for calculating the height of pyramids and the distance of ships at sea. Now we're going to dig into that pyramid story in detail in a moment, because it's both brilliant and possibly complete nonsense. Historians still argue about whether it actually happened. But the method? The method is genius. What Thales understood, and this is the key insight, is that mathematics isn't just about counting things. It's about finding relationships, patterns, proportions, universal principles that apply everywhere. He took practical problems and transformed them into theoretical knowledge. And then, and this is crucial, he took that theoretical knowledge and applied it back to practical problems. This is the birth of applied mathematics. This is the moment when human beings realized we could use abstract reasoning to solve concrete problems. Okay, let's get into the weeds a bit with Thales' theorem, because this is where we see his genius most clearly. The theorem states, if you have points A, B, and C on a circle, and AC is the diameter of that circle, then angle ABC, the angle at point B, is always a right angle. Always. Every single time. Now, why is this true? And more importantly, how did Thales prove it? Here's what's remarkable. Thales used the properties of isosceles triangles. He understood that if you draw lines from the center of the circle to points B and C, you create 2 isosceles triangles. And because the angles in any triangle sum to 180 degrees, and because of the special properties of these isosceles triangles, the angle at B must be 90 degrees. It's elegant. It's beautiful. It's the kind of proof that makes you go, oh, of course that's true once you see it. But here's what really matters. This wasn't just an interesting geometric curiosity. This theorem became absolutely foundational to Euclidean geometry. When Euclid wrote his Elements a few centuries later, basically the most influential mathematics textbook in human history, Thales' insights were baked right into the foundation. You know, I remember the first time I really understood this theorem. Not just memorized it for a test, but actually got it. I was probably about your age, sitting in a geometry class, half asleep, and suddenly it just clicked. The relationship between the circle and the triangle, the inevitability of that right angle, I literally sat up straight in my chair. The teacher thought I was having a medical emergency. But that's what good mathematics does. It wakes you up. It shows you that the universe has structure, has order, has these beautiful, eternal relationships that we can discover and understand. Now, let's talk about applications, because this isn't just abstract beauty, though the beauty matters. Thales' theorem gives us a way to construct perfect right angles using nothing but a circle and a straight edge. Think about what that means for ancient builders, for architects, for anyone who needs to create perpendicular lines, which is basically everyone who builds anything. You don't need fancy tools. You don't need divine inspiration. You just need to understand the relationship between circles and triangles, and you can create perfect right angles every single time. And this is what Thales was really doing. He was showing that the universe operates according to rational principles that humans can discover and use. Not magic, not divine favor, not secret knowledge passed down from the gods. Just observation, reason, and logical proof. Every time you use a carpenter's square, every time you see a building with perfect right angles, every time you encounter anything that relies on geometric precision, you're seeing Thales' legacy. You're seeing the power of human reason to unlock the secrets of reality. Of course, Thales didn't stop there, because apparently proving fundamental theorems of geometry wasn't enough to keep him busy. No, he also decided to measure the Great Pyramid of Giza using shadows. And that story, which may or may not be true, but is definitely awesome, that's what we're going to look at next. Because it shows Thales at his most clever, his most practical, and his most, I'm going to solve this problem using nothing but basic geometry and sheer audacity. So let's talk about pyramids, shadows, and why historians still argue about whether this actually happened. Alright, so imagine you're standing in front of the Great Pyramid of Giza. It's already ancient when Thales sees it, built over 2,000 years before his time. This thing is massive. We're talking 481 feet tall originally, covering 13 acres at the base. It's one of the most impressive structures human beings have ever built. And some Egyptian guide, probably used to impressing tourists, says to Thales, "Pretty amazing, right? Nobody knows exactly how tall it is." And Thales, being Thales, apparently said, "Hold my wine. I'll figure it out." Now I want you to appreciate the sheer audacity of this moment. You can't exactly climb to the top with a measuring tape. You can't see the top and the base at the same time to triangulate. The Egyptians who built it didn't leave the blueprints lying around, but Thales had something better than blueprints. He had geometry, and he had shadows. Here's how the story goes, and I want to emphasize, this is legend. We're not 100% certain this actually happened, but the method is absolutely sound. Thales waited for a specific time of day, the moment when the length of his own shadow equaled his height. You know this moment. It happens twice a day, when the sun is at a particular angle, around 45 degrees above the horizon. At that exact moment, he measured the pyramid's shadow, and because of the proportional relationship he'd discovered, because at that angle, height equals shadow length for any object, the pyramid's shadow gave him the pyramid's height. Well, almost. He had to add half the length of the pyramid's base, because the shadow extends from the center point, not the edge. Do you see what he did here? He took an impossible problem, measuring something impossibly tall, and transformed it into a simple problem. He used the relationship between similar triangles, the predictable movement of the sun, and basic proportional reasoning. No fancy equipment, no divine revelation, just observation, patience, and mathematical insight. This is applied geometry at its finest. This is the human mind looking at reality and saying, I can figure this out. I can measure the unmeasurable. Now here's where it gets fun. Modern historians love to argue about this story. Some say it definitely happened. We have multiple ancient sources mentioning it. Others say it's too good to be true, probably embellished over time. One historian pointed out that Thales would have needed to account for the pyramid's slope, the irregular shape of the shadow, atmospheric refraction. To which I say maybe he did, or maybe he got close enough that the Egyptians were impressed, and that's what mattered. The story doesn't claim he calculated it to the millimeter. It claims he figured out a clever method to get a reasonable measurement. But here's what really matters. Whether or not this specific story is true, we know Thales developed methods for using proportions and similar triangles to measure distant objects. We know he understood the relationship between an object's height and its shadow. We know he applied geometric principles to practical problems. The pyramid story is memorable because it's dramatic. But the real achievement is the method, the insight that you can use mathematics to solve problems that seem impossible. And speaking of seemingly impossible achievements, let's talk about that solar eclipse. Okay, we need to talk about what might be the most famous thing Thales ever did. The solar eclipse of 585 BCE, the one that stopped a war. Now, I started this lecture with this story because it's dramatic and it hooks your attention. But now let's dig into what actually happened, or what we think happened, and why it matters. According to the ancient historian Herodotus, Thales predicted that a solar eclipse would occur in a particular year, and it did. On May 28, 585 BCE, the sun went dark right in the middle of a battle between the Lydians and the Medes. Both armies interpreted this as a sign from the gods. They stopped fighting. They negotiated peace. The eclipse literally ended a war. But here's what's absolutely remarkable about this. If Thales actually predicted this eclipse, and that's a big if we'll get to in a moment, then he was using astronomical knowledge to forecast a celestial event. Think about what that means. He was saying, the universe operates according to patterns, predictable patterns. Patterns we can understand and use to know what will happen in the future. This isn't prophecy, this isn't divine revelation, this is science. This is the scientific method in embryonic form. Observe patterns, develop a theory, make predictions, test those predictions against reality. Now here's where modern scholars get all worked up and start throwing shade at poor Thales. Well, actually, Professor Leshley, the Babylonians had eclipse cycles, but they could only predict lunar eclipses with any accuracy. Solar eclipses are much harder because you need to know the exact location where the eclipse will be visible. The mathematics required to predict a solar eclipse visible from a specific location in Asia Minor wouldn't be developed for centuries. Okay, fair points. The skeptics might be right. Maybe Herodotus got the story wrong? Maybe Thales predicted an eclipse but not the eclipse. Maybe he got lucky. Maybe the whole thing is apocryphal. But here's what we do know for certain. First, there was a solar eclipse on May 28, 585 BCE, visible from Asia Minor. Modern astronomy confirms this, so the eclipse part of the story is definitely true. Second, Thales had access to Babylonian astronomical records. He traveled, he studied, he knew about eclipse cycles, the Saros cycle, which repeats every 18 years and 11 days. Third, even if he couldn't predict the exact time and place with modern precision, he could have made an educated guess that an eclipse was likely in a particular year or season. And here's what really matters. Whether the prediction was precise or approximate, whether it was skill or luck, the story tells us something crucial about how Thales was perceived. His contemporaries believed he could predict celestial events using natural knowledge. They believed he understood patterns in the cosmos. They believed human reason could unlock the secrets of the heavens. That belief, that conviction that the universe is knowable, that it operates according to natural laws we can discover, that is Thales's real legacy. Not the specific eclipse prediction, but the entire worldview it represents. This is the birth of the scientific worldview. The idea that 1. The universe operates according to natural laws. 2. These laws are consistent and predictable. 3. Human beings can discover these laws through observation and reason. 4. We can use this knowledge to make predictions about the future. Every scientific achievement since Thales, every discovery, every technological advancement, every time we've used knowledge to improve human life, rests on these foundational assumptions. You know, I sometimes wonder what Thales would think if he could see us now. We can predict eclipses centuries in advance down to the second. We've sent robots to Mars. We've photographed black holes. Would he be surprised? Or would he just nod and say, yeah, that's what happens when you pay attention to patterns and use your brain. Took you long enough. I like to think it would be the latter. But we've been talking about Thales the mathematician, Thales the astronomer, Thales the practical problem solver. Now it's time to talk about Thales the philosopher. Because his most influential idea, the one that really launched Western philosophy, wasn't about triangles or eclipses or pyramids. It was about water. Yeah, water. Everything is water, according to Thales. And before you laugh, And trust me, your first instinct is to laugh. Let me explain why this seemingly ridiculous idea is actually one of the most important philosophical insights in human history. Alright, so water. Everything is water. I can see some of you looking at your desks right now, tapping on the wood, thinking, Professor Leshley, I'm pretty sure this desk is not water. I'm pretty sure I'm not water. I'm pretty sure Thales lost his mind somewhere between measuring pyramids and making wild claims about the fundamental nature of reality. And look, I get it. On the surface, pun intended, this sounds absolutely bonkers. But stay with me here, because what Thales was actually doing is so much more sophisticated than it first appears. Here's what Thales was really asking. What is the fundamental substance of the universe? What is the one thing that everything else comes from? Now, why is this question revolutionary? Because before Thales, the answer would have been, the gods made everything. Zeus did this, Poseidon did that. Different gods made different things for different reasons. Thales said, no. I think there's one underlying substance, one fundamental material that takes different forms to create everything we see. This is monism, the idea that reality is fundamentally unified. That beneath all the apparent diversity, rocks, trees, animals, humans, stars, there's a single common substance. And this changes everything. Because if everything comes from one substance, then the universe isn't a chaotic mess of competing divine wills. It's a unified system. It operates according to consistent principles. It can be understood. So why water specifically? Well, Thales wasn't just pulling this out of thin air or out of water, I suppose. He had reasons. Look at what he observed. First, all life depends on water. Plants need it, animals need it, humans need it. No water, no life. That's a pretty fundamental role right there. Second, water exists in multiple states. It's liquid in rivers and oceans. It's solid as ice. It's vapor in clouds and steam. Here's a single substance that can transform itself into radically different forms. Think about what that means. Thales is looking at water and seeing a model for how one substance could become many things. Ice doesn't look like steam, but they're both water. Maybe, just maybe, everything that looks different is actually the same fundamental substance in different forms. Third, land seems to emerge from water. Islands rise from the sea. The Nile floods and deposits fertile soil. Thales lived in a coastal city. He saw how water and earth interact constantly. Now, was Thales right? Obviously not, in the literal sense. We know now that matter is made of atoms, that there are over 100 elements, that water itself is a compound of hydrogen and oxygen. But here's what Thales got right. He understood that there's an underlying unity to nature, that what appears diverse might share common principles. That transformation is possible, that substances can change form while maintaining some essential identity. Modern chemistry, modern physics, they're still asking Thales' question. What is everything made of? We've just gotten more sophisticated answers. Atoms, subatomic particles, quantum fields, maybe strings. But the question, that's pure Thales. And here's the really crucial part. Thales was proposing a natural explanation. Not the gods did it, not it's a mystery beyond human understanding, but there's a natural substance that behaves according to natural principles. This is the birth of natural philosophy, the ancestor of what we now call science. Look at this phrase on the slide, a monistic view. This is one of the fundamental questions in philosophy. Is reality fundamentally one thing or many things? Is the universe unified or fragmented? Thales came down firmly on the side of unity, and that choice, that commitment to finding underlying patterns and common principles, that's what makes science possible. Now, I know what you're thinking. Okay, Professor, I get that the question was important. But seriously? Water? He couldn't have picked something a little less wet? Fair enough. His student Anaximander thought Thales was too specific. He proposed something called the apeiron, the infinite, undefined, boundless something or other that everything comes from. Another student, Anaximenes, said, No, it's obviously AIR. Everything is air. So there was definitely some disagreement in the Milesian school about what the primal substance actually was. But here's what they all agreed on. There is a primal substance. The universe is fundamentally unified. Nature operates according to natural principles that human reason can discover. That consensus, that shared commitment to rational inquiry into nature, that's what launched Western philosophy and science. Okay, so Thales thinks everything is water. That's weird enough. But then he makes another claim that sounds even stranger to modern ears. Everything has a soul, not just living things. Not just humans or animals, everything, rocks, rivers, magnets, the whole universe is alive, according to Thales. Now, before you write him off as completely out there, let's talk about what he actually observed and what he was trying to explain. Thales was the first Greek philosopher we know of to study magnets systematically. He observed that lodestone, a naturally magnetic iron ore, could attract iron. It could make iron move without touching it. Think about how weird that is if you've never encountered the concept of magnetism before. Here's a rock that can make other objects move from a distance. No visible connection, no obvious mechanism, just action at a distance. How do you explain that? In Thales' worldview, where everything operates according to natural principles, how do you account for a rock that seems to have the power to move things? His answer? The magnet has a soul. It has some kind of animating force, some vital principle that gives it the power to act. Now, I can hear the objections already. Professor Leshley, that's not a soul, that's a magnetic field. We understand magnetism now. It's one of the fundamental forces of nature. Yes, exactly. It is one of the fundamental forces of nature. But Thales didn't have the concept of fundamental forces. He didn't have field theory. He didn't have Maxwell's equations. What he had was the observation that some objects have the power to affect other objects without direct contact. And his explanation, crude as it sounds to us, was an attempt to account for that power using the conceptual tools available to him. So what did Thales mean by soul? Not what we mean today. Not consciousness, not personality, not the thing that goes to heaven or gets reincarnated. For Thales, soul meant something more like animating principle, or power of motion or vital force. Look at this phrase. The soul is a force that permeates all things. Thales believed that there was some kind of vital energy running through the entire universe. That everything, not just obviously living things, participated in this cosmic aliveness. This is called high-lozoism, the idea that matter itself is alive, that there's no sharp distinction between living and non-living things. Now, is this true? Well, no, not in the way Thales thought. We don't think rocks are alive. We don't think magnets have souls. But here's what's fascinating. Thales was grappling with a real problem. How do we explain causation? How do we explain why things happen? What gives objects the power to affect other objects? Modern physics is still asking these questions. What is a force? What is energy? How does causation actually work at the quantum level? We have better answers than Thales, but we're asking his questions. And here's something else to consider. Thales' view of the soul had profound implications for how he saw the universe. If everything has soul, if everything participates in this vital force, then the universe is fundamentally alive. It's not dead matter being pushed around by external forces. It's a living, dynamic, interconnected system. This connects directly to his idea about water as the primal substance. Water flows, water moves, water seems alive. Maybe that's part of why he chose it, because it embodies this principle of vitality, of constant motion and transformation. Now, Thales' ideas about the soul influenced later philosophers in ways that are kind of hilarious if you know the history. Plato took the idea of soul and ran with it in a completely different direction. The soul as the immortal, rational part of humans that exists before birth and after death. Aristotle wrote an entire treatise called On the Soul, where he systematically disagrees with almost everything his predecessors said about it. So Thales started a conversation that philosophers are still having 2,600 years later. Not bad for a guy who thought magnets were alive. But here's the deeper point. Thales was trying to create a unified theory of reality. Everything is water. Everything has soul. Everything is connected. Everything operates according to natural principles. He was looking for the underlying unity beneath apparent diversity. He was trying to explain how the universe works without appealing to mythology or divine intervention. And this commitment to natural explanation, this search for underlying unity, this conviction that human reason can understand reality. This is what makes Thales the father of Western philosophy. Not because he got everything right. He didn't. But because he asked the right questions. Because he insisted on natural explanations. Because he believed the universe made sense and we could figure it out. Look at that last bullet point. Influence on later philosophers. Plato, Aristotle, the Stoics, medieval philosophers, modern philosophers, they're all responding to questions Thales first raised. What is the fundamental nature of reality? How do we explain change and motion? What is the relationship between unity and diversity? What is the soul? These aren't just historical curiosities. These are live philosophical questions. We're still working on them, so we've seen Thales the mathematician, Thales the astronomer, Thales the natural philosopher with his water and his souls and his magnets. Now let's zoom out and look at his broader impact. Because Thales didn't just have interesting ideas, he started a whole tradition. He founded a school. He inspired students who went on to develop their own philosophical systems. Let's talk about the Milesian school and how Thales' legacy shaped the entire trajectory of Western thought. Alright, so here's what happens when you're the first person to say, hey, maybe we should explain the universe using reason instead of mythology. You start a movement. Thales didn't just have interesting ideas and then disappear into history. He taught students. He inspired followers. He created what we now call the Milesian school, the first philosophical school in Western history. And his students? They didn't just memorize his teachings and repeat them. They argued with him. They developed their own theories. They pushed his ideas in new directions. This is what real intellectual tradition looks like. Not blind acceptance, but creative disagreement. Not the master said it, so it must be true, but the master said it, and here's why I think he was wrong. Let's look at two of Thales' most important students, Anaximander and Anaximenes. First, Anaximander. Now, Anaximander looked at his teacher's theory, everything is water, and said, I appreciate what you're trying to do here, Thales, but I think you're being too specific. Why water? Why not fire? Why not air? Why not earth? If you pick any particular substance as the fundamental stuff of reality, you're going to have trouble explaining how it becomes all the other substances. So Anaximander proposed something brilliantly abstract, the apeiron, the boundless, the infinite, the undefined. Think about how sophisticated this is. Anaximander is saying, the fundamental reality can't be any specific thing we observe in nature. It has to be something more basic, more primordial, something that contains the potential for all specific things, but isn't itself any particular thing. This is a huge conceptual leap. This is moving from concrete observation to abstract theorizing. This is philosophy getting more philosophical. And Anaximander didn't stop there. He developed the first known map of the world. He proposed that the Earth floats freely in space, unsupported, which was a radical idea when everyone assumed it had to be resting on something. He developed an early theory of evolution, suggesting that humans evolved from fish. The guy was a genius, and he got there by taking Thales' approach, natural explanation, rational inquiry, and pushing it further. Now the other student, Anaximenes, looked at both Thales and Anaximander and basically said, you're both overthinking this. Thales says water. Anaximander says the infinite, undefined, boundless whatever. Anaximenes says it's air. Obviously it's air. Look, air can become denser and turn into water, then ice. Air can become rarer and turn into fire. Air is everywhere. Air is what we breathe. It's literally the stuff of life. Case closed. Now, you might think this is a step backward, going from Anaximander's sophisticated abstraction back to a concrete substance. But actually, Anaximenes was doing something clever. He was trying to explain the mechanism of transformation. See, Thales said everything is water, but he didn't really explain how water becomes other things. Anaximander said everything comes from the apeiron, but that's so abstract it's hard to work with. Anaximenes said, air transforms through rarefaction and condensation. It gets thinner or thicker, and this gives you a mechanical explanation for how one substance becomes many different things. This is important. This is the beginning of trying to explain not just what things are made of, but how transformation actually works. But here's what I want you to notice. All three of these philosophers, Thales, Anaximander, Anaximenes, they're all asking the same fundamental question. What is the underlying unity of reality? They disagree about the answer, water, apeiron, air. But they agree about the question. They agree that there is an underlying unity. They agree that it can be discovered through reason. They agree that natural explanations are better than mythological ones. This is what a philosophical tradition looks like. Not everyone agreeing, but everyone engaged in the same inquiry. Not blind acceptance, but creative development. Each thinker building on and arguing with what came before. Look at this phrase. A legacy of inquiry. That's what Thales really gave us. Not the right answers, he got plenty of things wrong, but the right approach, the right questions, the right attitude toward knowledge, curiosity, reason, evidence, argument, revision. These are the tools of philosophy. These are the tools of science. And Thales and his students were the first to use them systematically. But the Milesian school was just the beginning. Thales' influence rippled out far beyond his immediate students. Let's zoom out even further and look at how Thales shaped the entire trajectory of Greek philosophy, and by extension, Western philosophy as a whole. Because here's the thing. Every major Greek philosopher after Thales is responding to the questions he raised and the approach he pioneered. The slide mentions the foundations of Western philosophy. Let me break down what that actually means. First, Thales established that philosophy is about rational inquiry into the nature of reality, not revelation, not tradition. Not because the gods said so, but observation, reason, and argument. Every philosopher after him, whether they agree with his conclusions or not, accepts this basic premise. Even Plato, who believes in transcendent forms and the immortal soul, makes arguments for these positions. He doesn't just appeal to religious authority. Think about how radical this is. For thousands of years, human societies explained the world through mythology. The gods did this. The spirits did that. The ancestors decreed this. Don't question it. Thales said, question it. Question everything. Use your mind. Look at the evidence. Make arguments. Be willing to be wrong. This is the birth of critical thinking. This is the moment when human beings claimed the right to understand reality for themselves. And once that door is opened, you can't close it. Once you've said, we can figure this out through reason, you've unleashed something unstoppable. The pre-Socratics, Heraclitus, Parmenides, Empedocles, Democritus, they're all following Thales' lead, asking questions about the fundamental nature of reality. Socrates takes Thales' method of questioning and applies it to ethics and human life. Plato takes the search for underlying unity and develops his theory of forms. Aristotle systematizes the whole enterprise, creating formal logic and organizing knowledge into different sciences. But let's look at the specific questions Thales raised that are still central to philosophy. 1. What is the fundamental nature of reality? Is there an underlying unity beneath apparent diversity? We're still asking this. Physicists are looking for a unified field theory. Philosophers debate monism versus pluralism. Same question, more sophisticated tools. 2. How do we explain change and transformation? How does one thing become another? Still asking this. Philosophy of science, metaphysics, even quantum mechanics, all grappling with the nature of change and causation. 3. What is the relationship between the natural and the divine? Can we explain the world without appealing to supernatural forces? Still asking this. The relationship between science and religion. Naturalism versus supernaturalism. These are live debates that trace back to Thales. 4. What can human reason discover? What are the limits and possibilities of rational inquiry? Still asking this. Epistemology, the study of knowledge, is still exploring questions Thales first raised about how we know what we know. You know what's kind of hilarious? Thales would probably be terrible in a modern philosophy department. Professor Thales, your theory that everything is water doesn't account for the atomic structure of matter, the periodic table of elements, or basic chemistry. Professor Thales, your claim that magnets have souls is inconsistent with our understanding of electromagnetic fields. Professor Thales, we're going to need you to revise and resubmit. But here's the thing. Being wrong about specific claims doesn't diminish the importance of asking the right questions and pioneering the right methods. Newton was wrong about absolute space and time. Einstein showed that. Does that make Newton unimportant? Of course not. Darwin didn't understand genetics. Does that make evolution unimportant? Obviously not. Thales' legacy isn't his specific theories. It's the entire framework he created for thinking about reality. Look at this phrase again. A legacy of inquiry. Not a legacy of answers, but a legacy of questions. Not a legacy of dogma, but a legacy of investigation. This is what makes Thales the father of Western philosophy. He showed us that. The universe is knowable, human reason is powerful, natural explanations are possible, questions are more important than inherited answers. Being wrong is part of the process of getting closer to truth. And here's what's remarkable. This tradition of inquiry that Thales started 2,600 years ago is still alive. Every time a scientist questions a theory and designs an experiment to test it, that's Thales. Every time a philosopher examines an assumption and asks, but is this really true? That's Thales. Every time you refuse to accept something just because that's how it's always been done and you ask, but why? That's Thales. The questions change. The tools get more sophisticated. Our understanding deepens. But the fundamental approach, rational inquiry into the nature of reality, that's the same approach Thales pioneered in Miletus 26 centuries ago. I sometimes imagine what Thales would think if he could see a modern university. The laboratories, the libraries, the computers, the accumulated knowledge of centuries. Would he be overwhelmed? Would he feel vindicated? I think he'd walk into a physics lab, watch someone doing an experiment, and nod approvingly. Yes, this is what I was talking about. Observe, measure, think, test. This is how you understand the world. Then he'd probably ask a bunch of annoying questions about quantum mechanics and get into an argument with the physicists, because that's what philosophers do. We ask questions, we challenge assumptions, we refuse to accept easy answers. That's the tradition Thales started, and it's alive and well. So we've seen Thales, the mathematician, the astronomer, the natural philosopher, the founder of a school, the father of Western philosophy. But there's one more question we need to address. Why does any of this matter? Why should you care about a guy who lived 2,600 years ago and thought everything was made of water? Let's talk about the significance of Thales for us, here today. Alright, so I've spent the last 45 minutes telling you how amazing Thales was, how revolutionary, how foundational to everything we think and do. Now let me tell you the truth. We're not actually sure about most of this. Welcome to ancient philosophy, where the sources are fragmentary, the stories are probably exaggerated, and half of what we know is educated guesswork. But here's the thing. This uncertainty, these controversies and debates, they're actually part of the story. They're part of what makes studying Thales interesting and important. Let's talk about the elephant in the room. How much of what I've told you actually happened? Did Thales really predict that eclipse? Historians argue about it. Some say yes, he had access to Babylonian eclipse cycles and made an educated prediction. Others say the story is apocryphal, added later to make him seem more impressive. Did he really measure the Great Pyramid using shadows? Maybe, probably. The method works, and it sounds like something he would do. But do we have definitive proof? No. Did he really corner the olive press market to prove philosophers aren't impractical? Great story, probably didn't happen. But it tells us something about how his contemporaries saw him, as someone who could have done that if he wanted to. Now you might think, Professor Leshley, if we're not sure what actually happened, why are we studying this? What's the point? Here's the point. We're not studying Thales to memorize facts for a test. We're studying him to understand how philosophical thinking emerged, how it developed, and what it means for us. Whether Thales predicted the eclipse or just an eclipse, the important thing is that people in his time believed rational inquiry could predict celestial events. That belief changed everything. Whether he measured the pyramid or just developed a method that could measure pyramids, the important thing is the method itself, the application of geometric reasoning to practical problems. The stories might be embellished, the details might be wrong, but the significance is real. The impact is undeniable. And then there's the question of what Thales actually meant by his various claims. When he said, everything is water, what did he mean? Was he talking about literal H2O? Was he talking about something more abstract? Fluidity, transformation, the principle of change? Was he using water as a metaphor for something else entirely? Scholars have been arguing about this for 2,600 years, and you know what? They're still arguing about it. When he said magnets have souls, was he being literal? Was he proposing a theory of universal animation? Or was he just trying to explain magnetic attraction using the conceptual tools available to him? We don't know. We can't know. Thales didn't leave us a detailed philosophical treatise explaining exactly what he meant. We have fragments, second-hand reports, and later interpretations. This drives some people crazy. They want definitive answers. They want to know exactly what Thales thought, exactly what he did, exactly what he meant. To which I say, get comfortable with uncertainty. This is philosophy. This is history. This is the human condition. We're always working with incomplete information. We're always interpreting. We're always making educated guesses based on limited evidence. And honestly, that's not a bug, it's a feature. Because here's what these controversies and debates teach us. First, critical thinking means being honest about what we know and what we don't know. It means distinguishing between this definitely happened, and this probably happened, and this might have happened, and this is a later legend. I could have just told you the stories as if they were unquestionable facts. That would have been easier, more dramatic, more satisfying, but it wouldn't have been honest. And it wouldn't have modeled the kind of thinking Thales himself pioneered. Careful, evidence-based, willing to acknowledge uncertainty. Second, interpretation matters. The same text, the same fragment, the same story can be understood in multiple ways. And arguing about interpretation, really digging into what something might mean, that's how we deepen our understanding. When scholars debate whether Thales meant literal water or something more abstract, they're not just arguing about ancient history. They're exploring fundamental questions about the nature of matter, the relationship between the concrete and the abstract, the role of metaphor in philosophical thinking. Third, the past is always being reinterpreted. Every generation looks at Thales through their own lens, asks their own questions, finds their own significance. In the 19th century, scholars saw Thales as the first scientist, the pioneer of rational empiricism. In the early 20th century, some saw him as a primitive thinker, still half stuck in mythological thinking. In the late 20th century, scholars started appreciating the sophistication of his questions even if his answers were wrong. Now, in the 21st century, we're asking new questions. How did cultural exchange with Egypt and Babylon influence his thinking? How does his work relate to non-Western philosophical traditions? What can his approach teach us about contemporary epistemological debates? Same Thales, different questions, different interpretations, and that's good. That's how intellectual traditions stay alive, by constantly being re-examined, reinterpreted, brought into dialogue with new concerns. You know what I think Thales would say about all these debates and controversies? Good. You're thinking. You're questioning. You're not just accepting what you're told. That's exactly what I wanted. Because ultimately, the point isn't to have perfect certainty about every detail of Thales' life and thought. The point is to engage with the questions he raised, the methods he pioneered, and the tradition he started. And that brings us to our final topic. All right, we're in the home stretch. We've covered a lot of ground: mathematics, astronomy, natural philosophy, the Milesian school, the birth of Western philosophy, scholarly controversies. Now let's distill this down. What are the actual, practical, applicable lessons from Thales' life and thought? Lesson 1. Curiosity and inquiry. Thales' life is a testament to the power of curiosity. He didn't just accept the world as he found it. He asked why. He asked how. He asked what if. Why does the Nile flood? How tall is that pyramid? What if there's a single substance underlying all of reality? What causes magnetic attraction? And here's what I want you to understand. Curiosity isn't just a personality trait. It's a choice. It's a practice. It's something you cultivate. You can go through life on autopilot, accepting what you're told, never questioning, never wondering. A lot of people do. Or you can choose curiosity. You can choose to ask questions. You can choose to wonder. You can choose to investigate. Thales chose curiosity, and that choice changed the world. What will you choose? Lesson 2. The power of reason. Thales demonstrated that human reason is powerful enough to understand reality. Not perfectly, not completely, but genuinely. We can observe patterns. We can make inferences. We can develop theories. We can test predictions. We can discover truths about the world that aren't immediately obvious to our senses. This is huge. This is the foundation of everything we call knowledge. But here's what often gets missed. Reason isn't just about being smart. It's about being disciplined. It's about following arguments where they lead, even when you don't like the conclusion. It's about changing your mind when the evidence demands it. Thales used reason to challenge traditional beliefs, to question inherited wisdom, to propose new explanations that contradicted what everyone knew to be true. That takes courage. It takes intellectual honesty. It takes a commitment to truth over comfort. Can you do that? Can you follow an argument where it leads even if it challenges your beliefs? Can you change your mind when the evidence demands it? That's what it means to honor Thales' legacy. Not just to think, but to think honestly. Lesson 3. The pursuit of fundamental truths. Thales wasn't content with surface explanations. He wanted to understand the underlying principles, the fundamental nature of reality. This is what separates philosophy from mere opinion sharing. Philosophy asks the deep questions, the foundational questions, the questions that everything else depends on. What is real? How do we know? What matters? How should we live? These aren't easy questions. They're not the kind of questions you answer once and move on. They're the kind of questions you wrestle with for a lifetime. But they're important questions. They're the questions that shape how you understand yourself, your life, your place in the universe. Thales showed us that these questions are worth pursuing, that the search for fundamental truths, even if we never arrive at final answers, is a worthy way to spend a human life. Now let me bring these 3 lessons together, because they're not really separate, they're interconnected. Curiosity drives you to ask questions. Reason gives you the tools to pursue answers. The commitment to fundamental truths gives you direction. It tells you which questions matter most. Together, these 3 things create what we might call the philosophical life. A life oriented toward understanding. A life committed to truth. A life that refuses to accept easy answers or comfortable illusions. And here's my question for you. Are you willing to live that kind of life? Are you willing to be curious even when it's uncomfortable? Even when the questions lead you to places you didn't expect? Are you willing to use reason even when it challenges your beliefs? Even when it requires you to admit you were wrong? Are you willing to pursue fundamental truths even when they're difficult? Even when the answers are uncertain? Because that's what Thales did. That's what every great philosopher since has done. That's what you can do if you choose. Now, I'm not saying this is easy. It's not. It's much easier to just accept what you're told, to go along with the crowd, to never question, never wonder, never dig deeper. Thales could have done that. He was wealthy. He was comfortable. He could have just enjoyed his life, made money in the olive oil business, and never bothered with all this philosophy stuff. But he didn't. He chose the harder path, the path of inquiry, the path of questioning, the path of seeking truth. And because he made that choice, we're sitting here 2,600 years later, still talking about him, still learning from him, still inspired by him. Look at these 3 lessons again. Curiosity and inquiry, the power of reason, the pursuit of fundamental truths. These aren't just historical observations about some ancient Greek philosopher. These are principles for living. These are tools for thinking. These are commitments that can shape your entire life. Thales showed us that a single person, armed with curiosity and reason, and a commitment to truth, can change the world, can start a revolution, can launch an entire tradition of thought that lasts for millennia. He didn't have modern technology. He didn't have the internet. He didn't have libraries full of books or universities full of scholars. He had his mind, he had his curiosity, he had his commitment to understanding, and that was enough. So here's my final challenge to you. You have more resources than Thales ever dreamed of. More information, more tools, more opportunities. What will you do with them? Will you use them to pursue truth, to ask deep questions, to understand reality more fully? Or will you let them distract you, entertain you, keep you comfortable but intellectually asleep? The choice is yours. It's always been yours. It will always be yours. Thales made his choice 2,600 years ago in Miletus. What choice will you make today? Be curious. Be rational. Pursue truth. Be like Thales. That's the lesson, that's the legacy, that's the challenge. Now go think about it.